Hi everybody. So real quick topic review for the test. We'll have local minimums and maximums, an absolute max and min as well, so you want to study those ideas. But really they're just visual. We want to complete the square. That's complete the square. Looks like complete, but that's actually supposed to be an E, and that piece is supposed to be the T. So complete the square. Still didn't get any better. So complete the square. We want to get points of intersection when we take a linear and a quadratic. Vertical asymptotes, which is basically domain. And then horizontal asymptote, oblique, or end behavior. Synthetic division, and be able to graph a parabola. So, very quickly, I kind of put together some things. So, here's a graph. This space right here, the squished table. So this space right here, we're looking in this region because this is higher than this. This is just a local maximum. This is the highest point, so it's the absolute maximum. This is a local minimum, but there is no absolute minimum because this graph goes off to negative infinity. Okay. So long division to find horizontal asymptotes or oblique or end behavior. So suppose our function is x cubed plus x plus 1 over x plus 1. Now note, I will ask you to get the vertical asymptotes as well. So you set that denominator equal to 0, and then you'll find out that the vertical asymptote is at x equals negative 1. So horizontal asymptote, this and this would have to have the same degree for it to be a horizontal asymptote, or the degree here would need to be smaller than the degree here. Oblique, this needs to be one more than this one. So we are looking at end behavior, and oblique and end behavior are both handled the same way. You just do long division. So you'll notice that I'm missing an x squared up here, so that's why I have a 0 in that spot. Okay, now I compare the firsts. This x and this x cubed. I need to multiply x by x squared to make it exactly the same as x cubed. Then I distribute to both and I get x cubed, and really it's plus x squared. But remember Frankenstein, so I draw the line and I change the signs. I have a negative x squared plus x plus 1. I compare the firsts, so I'm going to multiply by negative x. So negative x times x is a negative x squared, and a negative x times a positive 1 is a negative x. But the reason you see these as both positives is you draw the line and you change the sign. Remember Frankenstein. Well, the x squareds go away, and I have 2x plus 1. So what do I multiply x by to get it exactly the same? Well, 2x. I'm sorry, 2, just 2. So now I go 2 times x, I get 2x, and then 2 times 1, I get 2. I draw the line, I change my signs, and so I end up with a negative 1 as my remainder. And so my end behavior is going to look like x squared minus x plus 2. Okay. Completing the square, really what you're doing is you're converting from standard notation in a parabola to a vertex form. So what you do, first of all, is you divide everything through by 2, so the lead coefficient on the x squared is 1. And so I really have x squared over 2, and remember you create a parking lot, is equal to x squared plus 2x, create a parking lot, plus 7 over 2. Now, the one thing that's attached to the x, you take half of, so that's 1, then you square it, and that goes into both parking lots. Okay? So now, we have this x squared plus 2x plus 1 plus 7 over 2. This will always factor to what you get from what you take when you take a half. So it'll become x plus 1 squared. See, that 1 right there is that 1 right there. Now, what I'm going to do is I'm going to undo my work. So I'm going to subtract 1, and I'm going to subtract 1. But that's really 2 over 2. So that's how I end up with 5 over 2. Then I'm going to multiply everything by 2. Each term gets a 2. So the 2's cancel here. The 2's cancel here. And I'm left with f of x is equal to 2 times x plus 1 squared, the quantity x plus 1 squared plus 5. And so my vertex is at -1, +5. Okay. Solving or finding points of intersection between a linear and a parabola. Well, basically the idea is there's this moment in time where the line and the parabola have the same coordinates, so the y values are the same. So we take this and we're going to put it in place of oops, ignore that. That's a typo. Total typo. So what we need to do is, because this y and this y are equal at that moment, we set them equal to each other, and we actually have x minus 3 is equal to x squared plus 4x. Move everything over, set it equal to 0, so minus x minus x. I have minus 3 is equal to x squared plus 3x. Bring the 3 over, it becomes positive. So I have 0 is equal to x squared plus 3x plus 3. To find out the x's, you can either, well, you're going to have to use the quadratic. You could complete the square if you wanted to. Once you get your x's, and I'm running out of time, so I've got to be quick about this. Once you get your x's, plug it back into either of these two functions to find your y's. Okay. Graphing a parabola. So I'll tip my hat a bit and I'll tell you that we're going to be using the standard form to graph. So you need your axis of symmetry, which has the equation x equals -b over 2a. You need your y-intercept, which is 0c. You need your x-intercepts. You use the quadratic formula, -b plus or minus square root of b squared minus 4ac all over 2a. And then you're expected to find a fifth point using the axis of symmetry. Okay, I hope that helps. I'll talk to you guys later.